The electrophilic addition reaction of alkene takes place in two steps. In the first step, the electrons from the double bond is going to go make a nucleophilic attack on this electropositive hydrogen, and the bond between the hydrogen and Br is going to break, and it's going to move on to the Br. And this is going to create as a carbocation. And in the next step, the Br minus is going to make a nucleophilic attack on this carbocation to give our final product. Now, since this reaction has got two steps, each of these steps is going to have their own transition state. And in the first step, this is how the transition state is going to look like. The transition state is generally represented by the large square bracket. And you also needed to use the symbol on the outside of that square bracket. So in this first transition state, there are two bonds that are in the process of breaking. The first bond that is breaking is the bond from the double bond, and the second bond that is breaking is the bond between the H and Br. So these two bonds are in the process of breaking, whereas this bond is in the process of forming. In the second step, once the carbocation is formed, the Br minus is going to go make a nucleophilic attack on this carbocation to form the new carbon-Br bond. Right? This is the new carbon-Br bond that is formed. So here in this transition state, this bond is getting partially formed, which is shown by the dotted lines. Okay, so in the transition state, the partially formed and partially broken bonds are shown by the dotted lines. This is the reaction coordinate diagram for the electrophilic addition of alkene with HBr. As you can see, there are two steps, and therefore there should be two transition states, and there should be one intermediate. So the reactants are first getting converted into carbocation, which is your first step. And this is the transition state for the first step. And the second step is where the carbocation is getting converted into the products, right? So this is where your carbocation is present. This is the energy of the carbocation. And this carbocation again needs to climb an energy barrier, reach the transition state. This is your transition state. And finally, it needs to come form the products. Here in this case, the product is at lower energy level, and therefore it is stable compared to the reactants. So when we put both of these reaction coordinates together, this is how it's going to look like, where this is your alkene, which has got a higher energy, and it climbs up the energy barrier to form the transition state, to get onto the transition state, and then it cannot stay there for a long time, right? So it has to get converted into some intermediate. This is the intermediate that's formed, which is the carbocation, and the carbocation intermediate is again unstable. It's not an actual compound, right? It cannot stay there for a long time. So it will climb another energy barrier, reach the transition state, and then finally come down to bring the products, to form the products. The alkyl halide is the product that is formed. So here in this case, this is the energy difference between the reactants and the products. And it has got a negative sign for delta G, which means this reaction is possible.